All right, hello again. This is Jeff Scott of Blackhawk Technical College. We've been going through the first 17 chapters from the iOS 9 App Development Essentials text for the 152-153 Mobile Web Development iOS class for the Spring 2016 semester at Blackhawk Technical College. As mentioned, I'm going to go over the first 17 chapters, the first 14 of which I finished. Chapters 15 and 17, just so you know, I'm going to do those two next. I'm going to do them out of order. But both of them, I'm going to show the stuff that's in the book. But there's really no code examples. These are more analytical and theoretical in nature. Chapter 16 is building an app. It's the first time in this text in 116 pages that they went without building a complete app. So we will do that in Chapter 16. So the author mentions that it's vital that you have a basic understanding of some of the methodologies involved in the architecture of creating an iOS application. And it says these are also referred to as design patterns. And in this chapter, they discuss the MVC or Model View Controller design pattern. They also discuss subclassing, delegation, and target action. All right, and believe me, as the author mentions right here, oops, that back up a little bit, sorry. The author says, come on, that if you are new to these concepts, they can seem a little daunting to begin with, but once you work with them more and more, they will at least ideally become easier for you to understand. All right. So, as mentioned there, and you can see it in the picture on the bottom of page 113, iOS consists of a number of different software layers, each of which provides programming framework. So, it says we've got here what? We've got the device hardware at the bottom, then the core operating system, core services, media services, and Cocoa Touch. It says some diagrams designed to graphically depict the iOS software stack show an additional box positioned above the Cocoa Touch layer to indicate the apps running on the device. The author has not done so because that's the way that he feels, evidently. All right. In general, as mentioned here on page 114, the higher level of layer you program to, the less effort and the fewer lines of code. That's why typically if you are programming an operating system, you're going to write a lot more code than you are if you're programming an actual application, which is, I believe, what the author is trying to say here. All right, so the first thing that's discussed here is model view control architecture. And I have talked about this before. I don't have any idea how successfully I have talked about it, but I have talked about it before, and we're going to talk about it right now, too. Again, I wish I could get this thing to... All right. So they mentioned in the days before object-oriented programming, there was a tendency to develop apps where the user interface was tightly tied to the code. Well, that's not a good thing. So, for example, if I wrote a Java app for a Mac, and then I wanted to take that Java app and run it again on a Windows machine, I might have to totally go back and rewrite it. Well, that didn't really make a lot of sense. All right. So as mentioned here, and this is on the middle of page 114, the author says the goal of using a model view controller design pattern is to divorce the logic and data handling code of the app from the presentation. Think of it this way, and I've given this example before. I'm going to give two examples. First of all, in some ways, you've been doing this all along. And what I mean is, what I've tried to hammer into your heads from the first semester here is when you were writing web apps, that you took your HTML and you put it in one file. You took your CSS and you put it in another file. you took your JavaScript and you put it in another file. In some ways, not totally, but in some ways, this is reminiscent of a model view control pattern, wherein here, the model is your HTML, the view is your CSS, and the controller is your JavaScript. All right? And that's kind of like what we're looking at in here. I've also mentioned, that I used to use a book for the Java class where literally you ran a program and a box came up. And on the box were two buttons. One said grow and one said shrink. And there was a little black dot in the middle of the screen. Every time you clicked the grow button, that black dot grew by a few pixels in size. Every time you clicked the shrink button, it got smaller by a few pixels in size. So what does this have to do with anything? What it was supposed to do is it was supposed to be modeling you blowing up a balloon. So what you were modeling there was a balloon. All right? The view was every time you clicked the grow or shrink button, the dot on the screen got bigger or smaller. And the controller were the buttons. All right? So they mention here that, again, it says the true value of using a model view controller is that the model knows absolutely nothing about the presentation of the application, and the view knows nothing about what's being modeled. All right, they are, as the author says, divorced from one another. All right, and it's the controller that allows messages to be sent back and forth between the two. Within the context of an environment such as iOS 9 SDK, as it says in Swift, the model, the view, and the controller components are objects. As it says, the way that the view controller interacts with a model is through the methods and properties that are exposed by the model object. This is no different from the way one interacts, basically in any kind of object-oriented environment. So they say here, in terms of a view controller's interactions, it says things get a little bit more complicated. So they talk on the bottom of page 114 to the top of page 115 about the target action pattern, and they also talk about IB outlets and actions. So as mentioned here, and you can see it on the screen, and it's on the bottom of page 114, when you create an iOS 9 app, you typically start with a user interface. That's your view. You use the interface builder tool, and that's your main.storyboard file. And you write the view controller and model code in Swift using Xcode. When the user interacts with objects in the view, an event is triggered. So in other words, Swift, like many other programming languages, is an event-driven language. So as it says there, an event is triggered. So they say here, the purpose of the target action pattern is to allow you to specify what happens when an event is triggered. For instance, what's going to happen when a button is clicked. Okay, that kind of thing. So as mentioned here, I'm down towards now I'm on the top of page 115, but as the author mentions, the process of wiring up a view object to a specific method is achieved using an action. And even more than that, it's achieved using what's called an IB action, or an action with the interface builder. An action is a method defined within a view controller object designed to be called when an event is triggered in a view object. This allows us to connect a view object created within the interface builder to the code, all right, that is supposed to make something happen. This is one of the ways to bridge the separation between the view and the controller in the model view controller design pattern. The opposite of an action, as mentioned, you can see it on the bottom here, is an outlet. Whereas an action allows a view object to call a method on a controller object, an outlet allows a view controller object method to directly access the properties of a view object. In other words, and they mention this at the bottom of the paragraph, An IB outlet is simply an instance variable that references the view object to which access is required. So in other words, it's a label or a text field or a button or whatever. All right. The next thing that's discussed here on the middle of page 115 is subclassing. And it's mentioned subclassing allows you to create a new class by deriving it from an existing class. And the new class can extend the functionality of the previous class. As they mentioned, we're going to see examples of it when we start working with view controllers. All right, so it should make more sense at that time. The last thing that's discussed in this chapter on the bottom of page 115 is the concept of delegation. And when you think of delegating, if I delegate, that means I'm giving responsibility to another. And what they're saying here is delegation allows an object to pass responsibility for performing one or more tasks to another object. As mentioned here, this allows the behavior of an object to be modified without having to go through the process of subclassing the object. All right, and they give an example here. We're going to see that, I believe at least, in much more depth and breadth of coverage as we go along. So I'm finished now with this chapter, but rather than going on to 16, which I will do, I'm going to skip 16 right now and quickly go over chapter 17, which is only about 3 or 4 pages, which is on understanding iOS 9 views, window hierarchy, and view hierarchy. So as soon as I turn there, all right, so that'll be the next chapter that we cover.